In this video, I'm going to show you how to calculate both standard deviation and standard error. Let's take a look at a practice data set to figure out how we can calculate both of these using that data set. When we calculate standard deviation, what we are doing is we are measuring how precise is the data in relationship to one another. In other words, we're saying how close are all of these data points? And more realistically, how close are they to an average? If I were to take these four numbers here, and let's say that the experiment we're doing is we're measuring the amount of time that it takes for somebody to run 100 meters, and we've done the trial 4 times, and this is our time in seconds. We find the first trial takes that individual 10.1 seconds. The second trial, it takes 10.6, 11.3 seconds for the third trial, and then their last one, 10.2 seconds. We figure out the average is right at around 10.6 seconds. And so our question becomes, how similar are all these data points to the average? That's what we're going to calculate first when we calculate standard deviation. The equation for standard deviation is the following. It is the square root of the sum of each individual trial minus the average squared divided by the number of trials we've run minus 1. In this particular equation, we actually have all of the values we need for x, x bar, which is our average, and n. In this case, our x bar is 10.6 seconds. That is the average of all the trials. N is 4, because we have run 4 trials in this experiment. Let's take a look at how this equation would look if we were to write it all out. Below, I'm showing you the calculation for standard deviation. What we've said is it is the sum of each individual trial minus the average squared. And so I've done that for each of the individual trials. I then divide this by the number of trials, which is 4, and subtract from it 1. Once I have the value for all of this here, I calculate the square root of that value. Let's take a look at this in a couple of steps to see how this all comes together. 10.1 minus 10.6 is going to be negative 0.5, and we're going to square that value. We're going to add that to the square root of 0. That will get added to the square root of 0.7, or sorry, it's 0.7 squared. And we'll add that to negative 0.4 squared. 4 minus 1 is going to be 3. And so when we perform this calculation here, what we're going to find is the answer for our standard deviation. Okay, so I've calculated out this equation here. I've gotten 0.9 over 3. And if we take the square root of this, then we are going to get the value of 0.55. And so that is our standard deviation for this equation. We're going to take this and go ahead and now calculate our standard error. To calculate the standard error of the mean, what we do is we take the standard deviation and divide it by the number of trials in our experiment. In this case here, what we have is 0.55 as our standard deviation. The number of trials we ran was 4, and so we take 0.55 and divide it by the square root of 4. That gets reduced to 0.55 divided by 2, and that then tells us our answer for standard error of the mean is 0.28. How do we report this data out then? Well, oftentimes what we are reporting out is the average plus or minus what we call 2 standard errors of the mean. In this case, 2 standard errors of our mean here is going to be 0.55. And so to report this data, we would say that it takes this individual 10.6 seconds plus or minus 0.55 seconds to complete 100 meters. What this means is that 95% of the time, if this person were to run 100 meters 100 times, then 95 times out of 100, it's going to take them 10.6 seconds and up to 10.6 seconds plus 0.55 seconds, or 10.66 seconds minus 0.55 seconds. We call this our 95% confidence intervals. In other words, 95% of the time, it's going to take them anywhere from 10.05 seconds up to 11.15 seconds. Well, I hope this video has helped you to understand standard deviation, standard error of the mean, and how we can report out this data.